All right, so for the next video here, we're going to talk about section 3.4, which is going to be the product and quotient rules. Now, these rules allow us to take two functions, f and g, and find derivatives, and if they're being multiplied, use a product rule. If they're being divided, use the quotient rule. So let's start off here with the first rule, which is going to be our product rule. So if f and g are differentiable, so if f and g are differentiable at x, then, and here's our product rule. So we have the derivative of two different functions of x. We'll call the first one f of x, and then we'll call the second one g of x. And remember, they're being multiplied, so that's hence the product rule. This is going to equal the derivative of f times g of x plus the first function, which is f of x, times the derivative of g of x. Sometimes you'll hear people refer to it as the derivative of the first times the second plus the first times the derivative of the second. Okay? A quick and easy way to kind of remember this is just remember you have two different functions, f and g, f prime g plus f g prime. Okay? So let's go ahead and I think let's just look at a really easy example. So the first example I'd like to go over, let's do d dx of x to the fourth times 4 times the square root of x plus, we'll do plus 1. Keep it simple. Okay? So in this example here, we have two different functions of x. We have x to the fourth, and then we have 4 times the square root of x plus 1. So I'm going to call this f and this g. Now, off to the right, we know the derivative using our product rule is going to be f prime g plus f g prime. So what I like to do when I'm learning this is I'm just going to label f is going to be x to the fourth, f prime is going to be 4x cubed, g equals 4 times the square root of x plus 1, and therefore g prime. Now remember, you got to take that square root of x and convert it. Let me write it down here. You got to convert this into x to the 1/2 power. So when you go ahead and find this derivative, it's going to be 4 times 1/2 x to the negative 1/2 plus 0, or 2x to the negative 1/2. Okay? So now that we know that, our derivative is going to equal f prime g, so 4x to the third times g, which is 4 times the square root of x plus 1, plus f, which is x to the fourth, times g prime, 2x to the negative 1/2. Now, depending upon the book and the instructor, you're going to have to simplify. So I'm going to go ahead and simplify this for us. So this first part I'll do over here on the right hand side. We have 4x to the third times 4x to the 1/2 plus 1. Now the reason why I converted the square root of x to x to the 1/2 is because when I go ahead and distribute, I'm going to get 16 x to the, now you got to be careful because when the bases are the same, you add the exponents together. So it's 3 over 1 plus 1/2, or another way to think about this is 6 over 2 plus 1/2, which equals 7 over 2, plus 4x to the third Okay, so this is just going to be the first part. So let me write this here. Sorry if there was a little hiccup in the recording. All right, so there's the first part. Now, the second part, plus x to the fourth times 2x to the negative 1/2. Once again, when the bases are the same, you add the exponents together. So this is going to be 4 over 1 minus 1/2, which another way to think about this is 8 over 2 minus 1/2, or 7 over 2. So give me 1 second. So this is going to be 2x to the 7 over 2. And then lastly, we have like terms right there. So 16 plus 2 is going to be 18. X to the 7 over 2 plus 4x to the third. And I am just going to leave it at that. I think this is already ugly enough with the 7 over 2 to as the exponent.